Hello everyone, welcome to my YouTube channel. So here today we are going to be looking at power, mainly power, but we are going to incorporate work done against friction, then the power. We are going to be able to solve all these questions. So if you haven't subscribed, kindly subscribe so that we can make more contents like this. So this is very powerful content, and you subscribing will encourage me to make more and more. So let's begin. So from our previous video, we defined work to be the product of the force and the distance moved in the direction of the force times the cosine of the angle theta. So this angle can be, if we have if you just here, if we have an incline like this, then for that incline we have the angle, let's say 30 degrees. Then they happen to say parallel. So if this is being pulled parallel to the incline, the angle between two parallel lines is 0 degrees. So the angle between two parallel lines is 0 degrees. So therefore, that is the angle that they are talking about when they say they are parallel to each other. Then for the frictional force, the frictional force will always act at an angle of 180 degrees, because if you have, let's say, an object like this, it is being pulled in this direction. Frictional force will oppose the motion like that. So from the point of application, it will be acting at 180 degrees. Even if it is at an incline like this, it will be like this. The angle, it is being pulled up like that, the frictional force will be opposing the motion like this. Now the angle made here is still 108. You can see that it's a straight line. So knowing that our frictional force is the product of our work done by friction is equal to the product of the force and the distance, we can be able to calculate the work done by friction by the cosine of theta, or the work done against anything. So let's begin with this one. We have let's say a block of 4 kg is pulled up a rough incline that makes an angle of 30 degrees with the horizontal over a distance of 5 meters by a force of 50 newtons parallel to the incline at a constant speed of 3 meters per second. The coefficient of kinetic friction is 0.3. Calculates the work done by the pulling force. Calculate the work done by against the friction. Calculate the work done, the power delivered. So first let's deal with the work, then we are going to deal with the power. So the ability to solve physics problems, you have to create images. So we have a rough incline at 30 degrees. So this is more like the general image. We have the rough incline like that. We have the box. Then if we extend the box, we are going to so on top we have the normal force. So remember, in your dynamics, the opposite to the normal force in this case is the mg cosine of our theta, like that. Always the force that acts down is the mg sine of our theta, where this theta is the angle of inclination. Then if the force is pulling up like that, this is the pulling force, that means to say the friction will be in the opposite direction like that. So that will be our frictional force. This is our pulling force, this is our frictional force, like that. So for the first one, it says calculate the work done by the pulling force. Now specifically the pulling force. So if you don't have the pulling force, you have to find it. But if they have given you, just use the pulling force. Now for some of you, you might be misled by 4 marks, which might confuse you. So we are going to say the work done by the pulling force should be equal to the product of the force and the distance times the cosine of our theta. Now this cosine of theta is the one that is attached to D. The one that is attached to D is the angle made. in this case it is parallel to the incline, it means to say it will be 0. So we have the force applied is 50 newtons times the distance that it moves. So the distance of the incline is 5, so 5 meters. So we are going to say by 5 meters times the cosine of the 0 degrees. This gives us our 50 by 5. 50 by 5 will be equal to 250. Cosine of 0 degrees is 1, so we have 250 joules. So you just finding this, you get your 4 marks there. Then calculate the work done by the friction. So even the work done by the friction will be equal to the frictional force times the d with the cosine of 180 degrees, like that. So now, knowing that the frictional force is equal to, we have according to your dynamics, the coefficient of kinetic friction times the normal force, and the normal force is known to be equal to, so if you look at this, the normal force is pointing up like that, then the downward force is the mg cosine of theta. Therefore, it will be the summation of forces in the y direction will be equal to 0. Why is 0? Because it is not leaving the incline, like so the box is moving like that, it is maintaining contact. So the summation of forces in the y is 0, unless if it was doing this, but it is maintaining contact. So therefore the summation of forces in the y is equal to 0. Now which forces are those? The normal force is pointing up, so we say the normal force minus the frictional, minus the mg cosine of theta, which is equal to 0. This goes this side, so the normal force will be equal to our mg cosine of our theta, like that. So this is the formula we're going to use. So this angle, which is the mg attached to mg, is the angle of inclination, if you remember your dynamics. So in this case it's 30 degrees. So we are going to have the normal force will be equal to our mass. Our mass is equivalent to 4 there. So let's move this a bit. So we have our 4 kg by our, okay, so let's just substitute direct. So knowing that our frictional force is equal to mu k, so mu k times the normal force, which is our mg cosine of theta. So our mu k is equal to, we have, according to this question, mu k is 0.3, so we have 0.3 times the 4 kg times the gravity, which is 9.8, times the cosine of our 180. So the angle, oh sorry, not 180, the one that is attached to cosine mg is, we use the angle of inclination, which is the cosine of 30 degrees in this case. So this will give us our 0.3 by our 4 times our 9.8, then by our cosine of our 30 degrees. Our frictional force will be equal to 10.184 newtons. So this will be our frictional force. Therefore, we are going to say the work done by the friction will be equal to the frictional force times the distance with the cosine of 180 degrees. This cosine is what is the relationship with the incline. So if we are told that if the force is parallel to the incline, it simply means to say also the frictional force has to be anti-parallel, meaning it's just pointing like that. It just anti-parallel to the 50 Newton force. They are in this more like same line but different directions. So that means to say this will be 180 degrees. So the frictional force is 10.184. The distance moved by the force will be the distance moved by the friction, because it will be acting at all points. So we have distance is 5 times the cosine of 180 degrees. 180 degrees. So when we press, we are going to have 10.184 times 5 times the cosine of 180 degrees. This gives us a value that will be equivalent to negative 50.92 joules. So this is the work done by friction. So the work done is negative 50.92 joules. Before we discuss power, we say power is the work done per unit time. So that is power. Now, in this case, when you look at the power delivered by the pulling force, so whatever they'll tell you to use is what you are going to use. So power delivered by the pulling force. Now in this case, you have the constant speed. You have the constant speed. So get the difference. So instantaneous, there's instantaneous power. So instantaneous power is the power delivered at that instant. So it is the power delivered at that instant. So this one, you can calculate the power at 2 seconds. You can calculate the power at the 3 second mark. You can calculate the power at the 4 second mark. So that is what we call instantaneous power, power at that instant. Then there's also this instantaneous power. First, before that, we also have the average power. The average power is the work done per time taken, or rather per total time, so it is per total time taken. So that is instantaneous power. Average power. So now, if the under instantaneous power, you can use this if the speed is constant. You can use the instantaneous power formula, or if they give you a particular time. So you understand this further as we look at the question. Now, average power, you use it when you want to calculate the whole power. Maybe they tell you after the 3 seconds. That is not instantaneous power, that is the average power. You will see when we look at a question. So now, we know that the power is equal to the work done. It is the rate of doing work, so it is the work done over the time taken. Now we also know that power is equal to work is equal to the product of the force and the distance. So that means over the time. Now it's okay if we write mathematically force times the distance over time. It's still the same. Someone who writes like this or someone who writes like this, it's still the same. But if you recall, distance over time is speed or velocity. So we have the power should be equal to force times the velocity. Distance over time is velocity. So this is the formula for instantaneous power, like that. So in this case, this is what we are going to use, since they have told us that the speed is constant. That means to say you can use the instantaneous power. So power delivered by the 50 Newton force, we can say that the power should be equal to force times the velocity. So the force delivered by the pulling force is 40 newtons times the velocity, which is 3 meters per second. We know that the units of power are watts, so we have 50 by 3. We are going to have 150 watts, like that. So this is the power for that one. Let's look at our next question. Okay, so we have this other question. A motor pulls a crate with a force of with a mass of 300 kg with a constant force by means of a light extensible rope, inextensible meaning it's not stretching, rope running over a light frictionless pulley as shown in the figure below. The coefficient of kinetic friction between the crate and the surface of the inclined plane is 0.2. So this is what we have. It's being moved like that by a tension, by a pulling force, which we do not know. So here we will have to struggle. If we are asked, let's say for the first one, calculate the magnitude of the frictional force acting between the crate and the surface of the inclined plane. So we know that the frictional force for our number one, the frictional force is equal to the coefficient of kinetic friction times the normal force. So in this case, we need to do this. So this will be our Fn. Then opposite the normal force is the mg cosine of theta. The one that will always be acting downwards is the mg sine of theta. Now if you look at this object, since it's being pulled up there, it means to say the frictional force will be in this direction. Now knowing that our frictional force is equal to mu k times Fn, so we are going to say, knowing that our Fn, summation of forces in the y, will be equal to 0. So we have the Fn minus our mg should be equal to 0. We take not mg but mg cosine of theta, which is the opposite one, is equal to 0. So Fn will be equal to mg cosine of theta, where this theta is the angle of inclination. In this case it's 25 degrees. So we are going to have, what is our force, our mass, 300 kg. So we say 300 kg by our 9.8 newtons per kg times our cosine of our angle is 25 degrees. So this gives us, we are going to have our 300 by 9.8 times our cosine of 25 degrees. So this gives us a value of 2664.545. So this is the normal force. Then we know that the frictional force is equal to the coefficient of kinetic friction times the normal force. So if you wanted, you can replace as we did in the previous example. So the frictional force will be equal to, what's our frictional force in this case? It's 0.2. So we are going to say 0.2 by our normal force, which is equivalent to 2664.545 newtons. So our frictional force in this case will be equivalent to, so we multiply by 0.2. This gives us a 532.91 newtons. So this is our frictional force. Knowing that that's the answer for that one, we are going to move on to this one. The crate moves up the incline at a constant speed of 1.5. Calculates the average power delivered by the motor while pulling the crate up. We don't have the time, but if the speed is constant, we can use the formula for instantaneous power. So in this case, we are going to say the average power will be the tension times the, so we have the tension times the speed. So we have the power, is it power or, yeah, so we have the power should be equal to the force times the velocity. Now if you look clearly, we have this object is being put up there. Now if we could have just replaced, if let's say we were given 60 newtons is the tension that is put in this side. We could have just said 60 times the velocity, but we don't have, therefore we use our dynamics knowledge. So the tension is being put this side, but it is being opposed by the frictional force and the mg sine of theta. So we are going to say summation of forces in the x, summation of forces in the x is equal to, there is acceleration. Now in this case, if the speed is constant, then the acceleration is 0. So therefore the summation of forces in the x, summation of forces in the x is equal to 0, like that. So which forces are there? So we have the tension. Tension is pulling this side. The opposing one is the mg sine of theta. So we have minus our mg sine of theta minus our other force is our frictional force, which is also acting in the opposite direction, should be equal to 0. Then we find the tension. So the tension will become equal to, so all these come this side, this comes this side, so it will be mg sine of our theta plus our frictional force, like this. It's just the frictional force, like that. So we have the tension should be equal to, our mass is 300 kg times our 9.8. Make sure that your mass is in kg, times the sine of, what is our angle theta? Our angle theta is 25 degrees. So we have 25 degrees, like that. Then after that, we are going to say plus our frictional force. Our frictional force in this case, we have found it to be 532.91 newtons. So we add, we have the 300 times 9.8 times the sine of 25. This gives us a value of 1242.5 plus our 532.91. So if we add these two, we are going to have the tension that will be equivalent to, so plus our 1242.5 plus our 532.91. This gives us a value that will be equivalent to, tension is equal to 1775.41, like that, joules. Oh sorry, tension is a force, so we have newtons. So if you find your tension, or rather the force that is pulling, you will be able to say the power delivered will be equal to the product of the force and the velocity, if we have constant velocity. So we are going to have our force, which will be equal to, we have 1000. So in this case, this force is the tension. So we have 1775.41 times the speed. So the speed is constant at 1.5 meters per second. So we are going to say 1.5 meters per second, which will be able to give us, so we have the newtons there. So we multiply by 1.5, we are going to get a 2663.115, like that. So this is what we have as our power in watts. So remember, the units for power are watts. Let's move on to our next question. So the first question says a 1500 kg car accelerates uniformly from rest to a speed of 10 meters per second in 3 seconds. Finds the work done on the car in this time. So we know that the work done, let's move this question. We know that the work done, let's say the work done, where are we? So let's say the work done is equal to the product of the force and the distance. Now, do we have the distance? We can find it. We can find the force. We can find the force using kinematics. But in this approach, just in case they have told you using the work energy theorem. So if they have told you over a specific time to find the work done on the car in this time, you can use, you're finding the overall work, so you can use the work energy theorem, which states that the net work done is equal to the change in the kinetic energy. So this formula will help you find the work done easily, and like finding the distance, finding the force, of which, due to rounding off, you can get a value that is not necessarily accurate because of rounding off. So we use the work energy theorem, which is the net work done is equal to the change in the kinetic energy. So how do we find the change? So the change is equal to the final kinetic energy minus, so if you're finding change, it's the subtraction minus the initial kinetic energy. So this is the net work done. So using the work energy theorem, it simplifies things. So the net work done is equal to the kinetic energy final, which is your half mv final squared minus half mv initial squared. So we have our half. What is our mass in this case? In fact, let's factorize what's common. Half and m are the same. Then we are going to remain with our v final squared when we factorize, but if you want, you can just replace minus v initial squared, but factorizing makes work easier. So the net work done is equal to half. What is our mass? Our mass is equivalent to, we have our mass of what is our mass? 1500. So we say 1500 kg by our final velocity. So it starts from rest to a speed of this. So we are going to say 10 squared minus our initial is 0 squared since it started at rest. So we have half by 1500 is 750 kg times, we have the 10 squared is 100, like that. So when we multiply, we are going to have our net work done will be equal to 75,000, like this. So this will be our work done in joules. So just using the work energy theorem, you are going to find it like that. If they want all the work done, that is the net work done, then we are told the average power delivered in 3 seconds. Average, we don't use the force times the velocity. No, average work done, especially if the speed is changing. It was from 0 to 10 meters per second. We don't use this formula unless if the speed is constant, or they want an instant, but they want for the whole 3 seconds. So we are going to use our, knowing our definition, our power is equal to the work done over the time taken. So this gives us, what is our work done? Our work done is equivalent to, we have found it to be 75,000 then over our time taken. So in this case, the time taken is 3 seconds. So this gives 75,000 divided by 3. We are going to have the power, which will be equal to 25,000 watts. So this is our average power, like that. So looking at this other one, we have the instantaneous power delivered by the engine at 2 seconds. So in this case, this is the instantaneous power. So instantaneous power can be given as the force times the velocity. So instantaneous power and the power delivered, the average power, are different components. So we are going to say, let's calculate the force. We know that force is equal to ma, like that. So what force is acting? Now the acceleration is equal to, we know that the acceleration is equal to velocity minus u over the time. Now the acceleration will be equal to, what's our final velocity? It is 10 meters per second minus the initial velocity is 0 meters per second over, what is our time? Our time is equivalent to 2 seconds. Oh, sorry, the time, not the time for the engine, but the acceleration. so the rate of change of speed. So we are going to use 3 unless you knew how fast it was moving at the 2-second mark. So we are going to say over our 3, not 2. So this gives us our A is equal to 10 minus 0 is 10. Then we have over our 3. Then meters per second squared. I avoid dividing to improve the accuracy of the answer. So if you want, you can divide. So our force should be equal to our mass, which is according to this is 1,500. So we say 1,500 kg by our acceleration, which is our 10 over 3 meters per second squared. So our force will be equal to, we are going to get our, this divided by this is 500 times 10, we are going to have 5,000 like this. So newtons like that. So we have the instantaneous power should be equal to force times the velocity, which will be, the force is 5,000 by the velocity, which they have given us as, okay, so there is need for us to know the velocity. Since we don't have the instantaneous power, you need to know the speed at that point. So the velocity, we know that from kinematics, velocity is equal to u plus our a t. So now we are dealing to at 2 seconds. We are looking at specifically at 2 seconds. So the velocity, final velocity is equal to, you are not going to say 10 because 10 is at 3 seconds. So u is 0, it started at rest, plus our acceleration has been found to be 10 over 3 times what is our time. So our time is 2 seconds like that. So this gives us velocity is equal to 10 times this is 20 over 3. So we have 20 over 3 as our meters per second as our velocity. So the power is equal to force times the velocity. Force, which is 5,000, times our velocity, which is our 20 over 3 meters per second. So the power will be 5,000 times our 20 divided by our 3. This gives us a value that will be equivalent to 33,333.33 watts. So this is the most accurate power that we have found because we were not rounding off. So this is our power like that. Let's move on to our next question. This other one, we have the diagram shows an elevator that has a mass of 1,500 kg and carries a passenger having a combined mass of 1,000. Carries passengers, so they are a lot. Then we have a constant frictional force of 5,000 retards its motion upwards. So it is going up, but the frictional force is retarding the force, meaning it's bringing it down like that. So we are going to have something like this. The first question says, draw a well labeled free body diagram showing all the forces acting on the lift. So what we can just do is that we can have the free body diagram like this, then just draw which forces are acting. I prefer we use the square. So we have something like this. Then just draw. The tension is pointing up. It is the one that is pulling like that. So we are going to call this one as our tension. Then the downwards forces will be, number 1, our FG. Our FG, which is the force that is being acted by gravity. So our force acted by gravity, which is our FG, this is equal to the mass times the gravity, which is the combined mass of the people and the passengers. So we have mass times c, then we have plus. Okay, let's use this big mass for the elevator since it's heavier, plus the other mass of the people times the gravity. We are literally just looking at weight. It's pointing downwards like that. Then we also have the frictional force, which is retarding the motion downwards. So this is our free body diagram. So we can just say where Fg is the combined weight, well labeled. So then we also have our Mg is weight of elevator. Then our Mg is combined mass of passengers. So this is basically what our free body diagram is. Then the second part says determine the power delivered by the motor to lift the elevator a constant speed of 4 meters per second. So here what we are just going to do is that we know to say the speed is constant, so we can use power should be equal to force times the distance, like that. So force times the distance. Now this force that is acting is the tension, so we need to find it. So we can say the summation of forces in the x direction, or sorry, in the y, it's going up, should be equal to 0. Why 0 instead of ma? Because the speed is constant, and if the speed is constant, the acceleration is equal to 0. So we are going to say the ones that are pointing up is the tension. So we are going to say tension minus the downward forces is the Fg minus the other downward forces, the frictional force, is equal to 0. So we have the tension minus this one, which is our m small g plus our small m, like that. So this is the combined weight of the passengers and the elevator. Then we have minus the frictional force should be equal to 0. So we have the tension minus what's our elevator. Our elevator is 1,500. So we say 1,500 like that times the 9.8 plus our mass of the passengers is 1,000 times the 9.8. Then we have minus the frictional force, which is equivalent to 5,000. So we have minus our 5,000 like that should be equal to 0. So the tension minus, so in brackets we have 1,500 by 9.8. This gives us 14,700. If we add plus our 1,000 multiplied by 9.8, this gives us a 24,000 altogether. So in brackets we have the 24,500, then we have minus 500 like that. 5,000 should be equal to this. So we have tension minus 24,500 minus 5,000 should be equal to 0. So tension minus, if you subtract those two, you are going to get a negative of so negative 24,500 minus the 5,000 will give us a value that will be equivalent to 29,500, which should be equal to 0. So the tension is equal to 29,500 like that. So this is our tension. So if this is our tension, we can now be able to say the power is equal to force times the velocity. In this case, it will be tension times the velocity because it is the one that is pulling. So power should be equal to the tension, which is 29,500 times the speed, which is our 4 meters per second. So our power should be equal to, we have 100 and so if we multiply this times 4, it will give us 118,000 watts as our power. We have at what average speed should the 70 kg student have to climb a 5 meter rope to match with the power output of this amount. So knowing that our power is equal to force times the velocity. Now what is the force? So this person is climbing. So if they are climbing, it simply means to say it is their weight that is acting as the force. It is their weight that is pulling them down. So the force will be equal to our mg times the velocity, like that. So this will be our power. So we are told at what average speed. So therefore, to leave v alone, we say mg over our mg, like that. So this gives us v should be equal to power over our mg. So this gives us v is equal to what is our power. Our power is equivalent to, we have the 150 watts over what is the mass of this person. It is 70 kg. So we say 70 kg by our 9.8 newtons per kg. Velocity should be equal to, so we are going to say 150 divided by our 70. So first 150 watts over 70 by 9.8, we are going to get our 686. So our velocity will be equal to, when we divide our 150 divided by 686, we are going to get our 0.22. So we have 0.22 meters per second. So this is our velocity, like that. Let's look at our last two questions, which have to do with efficiency. Power input, power output. So I'll give you a simple way of understanding this. So we have this question first. So how do you answer this one? An engine pumps 2 tons of water in 1 minute to an average height of 10 meters. Calculate the power of the engine if 30% of the energy is wasted. So one thing that you need to know is that efficiency is how I can say in other words is how productive something is. The goodness of something is efficiency. So efficiency is calculated as the power output over the power input. Now, how you understand this is this. You always know to say power output is on top because the power output is less. And if you want to calculate the ratio of something, you have to divide what is less over what is higher. Like for example, if you buy, let's say, fuel for 50 kwacha, let's say this fuel for 50 kwacha, ideally it's supposed to get you a distance from, let's say, a town such as Ndola to Kitwe. So this is the ideal way. Now, because of certain things such as friction and all that, you will find that before, let's say if this is Kitwe, this is Ndola, before reaching Kitwe, the car fails to reach, like that. So that is the power output. It is how much is actually used as your power. Then the power input is the amount that you put, and you have an expectation of what you expect to have. Even when you buy electricity for, let's say, 200, you expect it to last one month. Then if it finishes, so this is the input, then you will find that the amount that was actually used was 180 because of certain things, wire conductivity and all that. So this is the efficiency, power output over power input. So now we have the efficiency. If the efficiency or 30% energy was wasted, meaning to say it was lost, so the efficiency in this case, we know that a percentage is out of 100. So we are going to say efficiency will be equal to, in this case, it will be 100% minus the wasted. So the efficiency will be equal to 100% minus the 30%, like that. So this gives us a 70%, like that. So this would be our efficiency. But I prefer we express it as a decimal point so that it's easier to calculate. A percent is always over 100. So we have 100%. This and this cancels. 100 divided by 70 divided by 100 is 0.7. So this is the efficiency. if that's the case, we are told an engine pumps 2 tons of water in 1 minute to an average height of 10 meters. So this is the power output, the outcome. What did it do is the power output. So in this case, it is pumping 2 tons of water. So a ton is 1000 kg. So 2 tons of water over this height. So there we can calculate the work. So we have the work, because we know to say from the work we can calculate the work over the time. We have the time, it is in 1 minute, so it will be work over time. So let's calculate the work. So we know that work is the product of the force and the distance. In this case, it is water is being pumped, so that means to say the weight of the water will act as the force, the weight, which is the mg. So it will be mg times the d. So what is our mass? Our mass is equivalent to 2 tons. So a 2 ton is 2 times 10 to the power 3. So 10 to the power 3 is 1000. So a ton is 2 to the power 3. So we have times the gravity, which is 9.8, times the distance, which is 10 meters. Make sure that your distance is in meters. So we have 2 times 10 to the power 3. If you want, you can just say 2000. Then we have times our 9.8 times our 10. So this gives us 196,000. So this is what we have. We have the work is that, then the power should be equal to, so you can be able to just say 1 ton is equal to 1000 kg. How about 2 tons is equal to x? When you do your calculation, you will end up with a 2000 that is here. So now the power is equal to the work over the time. So this is the amount that was done. So that is your power output. So the power output should be equal to, what is our work? Our work is 196,000 over the time taken, which is 1 minute. 1 minute is equivalent to 60 seconds. So it has to be in seconds. So we are going to say 60 seconds. If it is another time, then you have to convert. So we have the joules there. So the power output should be equal to how much did it accomplish? 196,000 divided by 60. This gives us 3266.67 watts. Therefore, efficiency, what are we required to find? We are required to find an engine pumps this. Calculate the power of the engine. So the power of the engine is the input, but due to friction, heat, and whatever, it may be reduced. So the power of the engine, so the efficiency will be equal to the power input, which is the engine. The power, it's more like put, over the power output. So let's make sorry, not power, we have reversed the equations. So remember what I said it is equal to, I said that it is equal to power out over the power input. So we have that's our efficiency. So with this, we are going to say, to find the power input, we are going to cross multiply. So it will be power input should be equal to power input by the efficiency should be equal to power output. We divide the efficiency. Our power input will be equal to power output over the efficiency. So this gives us power output is equivalent to we have the 3266.67 over the efficiency of 0.7. This gives us, divided by 0.7, we have 4666.67 watts. So this is the power input or the power of the engine. Let's look at our final question. This one says a pump on the ground floor of a building can pump up water to fill a tank of volume 30 cubic centimeters in 30 minutes if the tank is 40 meters above ground and efficiency of the pump is 40%. How much electric power is consumed by the pump? So in this case, what are we going to do? So we are going to say, we know that as long as we are dealing with, okay, so this question is interesting. We have a pump on the ground floor of a building can pump up water to fill a tank of volume 30 cubic centimeters in 30 minutes if the tank is 40 meters above the ground and the efficiency of the pump is 40%. How much electric power is consumed by the pump? So in this case, what we are simply going to do is that we are going to find the power, how much it has achieved. That will be our power output, then divide it by the efficiency. So now, looking at the fact that it is dealing with water, fill up a tank in 30 seconds if the tank is 40 meters above, so it needs to take it above. So that means to say, we know that the power is equal to work over the time. We also know that the work is equal to force times distance over the time. That means to say, and our force in this case, since it is being pulled up, its weight, so it will be the mg, that is resisting, times the distance in this is the height over the time. Now, do we know the mass? No, but we know the volume. So if this is water, the density is 1. So we have the density is equal to mass over volume, never forgetting. Density of water is 1 gram per cubic centimeters, should be equal to the mass unknown over the volume, which is 30 cubic centimeters. We are going to cross multiply. This gives us 1 gram per cubic centimeters times 30 cubic centimeters should be equal to the mass. So we have our 1 by 30. This will give us our 30 grams should be equal to the mass. Convert this, make sure that it is in grams, in kg. So you can say 1000 grams is equal to 1 kg. And you're going to say, how about 30 grams? It is equal to x. You cross multiply. So it will be 1000 x is equal to 30 grams by 1 kg. So we have grams there. Divide the 1000, divide the 1000. So this gives us our x is equal to, we have our 30 divided by 1000. This gives us a value that will be equivalent to 0.03. So we have 0.03 kg like that. Then also convert the time from how many minutes? 30 minutes to seconds. So we know that 1 minute is equivalent to 60 seconds. How about 30 minutes? It's equal to x. We cross multiply. It will be x will be equal to 30 times the 60 second, which will be 1800 if I'm not mistaken. 30 by 60 will give us 1800 seconds. So we have everything. So all we have to do is substitute. So we are saying power is equal to mgh over the time. So our m is 0.03 kg by our gravity is 9.8 newtons per kg times what is our height. Our height is equal to, we are told that it's 4 meters, then over the time is 1800 seconds. So this gives us, when we multiply on top 0.03 times 9.8 times our 40 divided by 1800, this is going to give us our 6.53 according to my calculator times 10 to the power of -3 watts. So this, the amount it has achieved, that's the power output. Then we are going to say, to find the power input, we have the power, the efficiency. Remember, efficiency is equal to power out over power in, cross multiply. So it will be power in by the efficiency. Efficiency should be equal to power out over the efficiency, which will give us the power in should be equal to the power out over the efficiency. What is our power output in this case? We have found it to be 6.53 times 10 to the power -3 watts. We divide the efficiency, which is 40%. So if you convert your 40%, you just divide by 100 to make it easier. So it will be 40 divided by 100 will be 0.4. Remember, a percentage is always out of 100. So 0.4, we put it there and divide. So the power in should be equal to 6.53 divided by 6.53 times 10 to the power -3 divided by 0.4 gives us a 0.016325 watts. So this is the power input. So that is how we deal with those questions. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial. Don't forget to give it a thumbs up so that our videos can reach a broader audience, and it would also encourage me to make more. See you in the next tutorial.